All right, this is section 6-10, last section of chapter 6. It's called Using Sampling to Predict. And a lot of this is just you're going to have to listen and pay attention and try to make sense of what's going on here. But there's vocabulary that's really important. So I would recommend definitely following along in your book as we do this. The first word is sample. And it says a sample is chosen from the larger group or population. So a sample is just a smaller version of an entire population. Say, for instance, an example, we want to know what the middle school students at Indian Valley think about food in the cafeteria. And so that would be the whole population. That's a population you want. Well, in order to see what the whole population thinks, you might not ask every single student. You might just take a sample. So you might just ask, a couple of the math classes, one 6th grade, one 7th grade, one 8th grade math class. That would be a sample of the entire population. And then you have what's called an unbiased sample, which is part of the representative of the larger population. It's selected at random, and it's large enough to provide accurate data. And the best samples are unbiased. A biased sample would be where you are favoring a certain crowd. You might ask the school, or you might try to find out what the school likes for the favorite sport of the school, and then you only ask the football team. Well, obviously, you're going to get most of them saying football. So that would be called biased sample. And then, so let's go over to example 1. Example 1 says, identify each sample as biased or unbiased and describe its type. Explain your reasoning. Letter A says, to determine the types of music her customers like, all the people attending a concert of a country music singer are surveyed. So you're trying to find out what music people like, and you only ask the people that are going to a country music singer's concert. Well, it says, since the customers at a country concert probably prefer country music, the sample is biased. So this is a bias sample. You're favoring country music by only asking people at a country music concert. That was example A, so A was biased. Let's go to B. B says, to determine the winner of a car, all of the employees' names are placed in a bin, and one name is chosen. Well, as we learned on the previous page, an unbiased sample is random, and everybody has an equal chance of getting selected. So this one would be unbiased. Every single person has an equal chance of being selected or having their name drawn. So it's completely random. Let's go to example number 2. Example 2. A has a pet store mailed a survey to all residents in the city to find out how many have pets. 50 people responded, and the results are in the table, so make sure you're paying attention to the book. Is this sampling method valid? If so, find how many dogs would you expect to be in the city if there are 1,585 residents overall. Explain your reasoning. So if you look at the table, there are 20 residents that have dogs out of the 50. So on this one, we've got 20 out of 50. And I think the sample is something that you could potentially set up a proportion for. So you're saying 20 out of 50 equals X out of 1585. And, if this were a valid sample, that is how you would solve to figure out how many people that you would predict to be dog people. But the problem is, as you read, it says this is a biased and voluntary response sample. since it only involves those who want to participate in the survey. So the only people that are in the table are people that responded to the survey. Not everybody responds. You're not taking everybody's opinions. You're not taking random people. They're people that say, yeah, I want to do that survey. I got time. So because of that, it's a biased sample. So therefore, none of this stuff works. All right, so that's the problem with doing a bias sample. And here's letter B. It says from a batch of 7,500 computer chips produced, the manufacturer sampled every 150th chip for defects and found that 2 were defective. Is this sampling method valid? If so, find how many of the 7,500 computer chips you can expect to be defective. Explain your reasoning. Well, this is systematic. This is completely, it is random because you're selecting every 150th chip. So in this one you have 2 are defective, but this is 2 out of every 50 chips. And how we get the 50 is, since we are selecting every 150th chip, and that's 150 out of every 7,500, there's 7,500 total chips, and we're surveying every 150th. So if we divide those two numbers, we get that there's actually 50 chips that we're going to end up sampling. So out of every 50 chips, we've got 2 that are defective. So we're going to take that to a total of 7,500 chips, and we're going to try to figure out what that exactly is. So 2 out of every 50 chips are defective, so how many out of 7,500 are defective? So here we get 50x equals 15,000. 2 times 7,500 is 15,000. And then we're going to divide by 50 to solve it. So x equals, we can cross off those zeros, 5 goes into 15 3 times, and then you got 0, 0. So my guess would be 300 chips are defective out of the total 7,500. And that is the end of 6-10 and the end of Chapter 6. Best of luck.